Welcome to the Trend Detection Podcast, powered by Siemens.
Hello and welcome to Trend Detection Podcast. My name's Jordan Walters. I'm a predictive maintenance engineer with Senseye Predictive Maintenance. And I'm joined here today by Stefan Lerbs. So Stefan, if you'd like to introduce yourself.
So hello also from my side. Thanks for having me. My name is Stefan Lerbs. I'm at Siemens e-mobility and I'm the head of digital services. My team and I, we develop data-driven services to optimize service operations, and we maximize the availability of our charging stations. And I'm happy to talk with you about the amazing project that we are doing at the moment.
Perfect. Thank you very much, Stefan. Yeah, I was going to ask you as well for like a little bit of background on the project, but I think you've summed it up quite nicely there. So I'll fill in a bit and just say it's primarily where we come in is with the monitoring of the electric vehicle chargers. And I know that, you've got a few different types of those chargers that you work with. But specifically in this project, we were focusing on the side charge D, correct?
That's correct. So maybe also for the audience that is not familiar with our portfolio at Siemens e-mobility, I think it makes sense to say a few words on it so we can categorize it a bit better. So Siemens e-mobility is a business unit at Siemens, and we cover more or less all aspects of smart, efficient charging infrastructure. So we have the hardware on the one side. That's what you were talking about. It's AC, so slow charging, and DC, fast charging. But we also have the software and services for these charging stations, and we have the entire package for our customers. And specifically with our high-power charging stations, we focus on the growing e-truck and e-bus segment. So there's a lot of news in the market that show that there's an extreme growth in these segments to decarbonize transportation, and we are supporting our customers with it. Just some numbers, I think it helps as well. So we have currently 1,400 employees. We have 80,000 charging stations installed in over 60 countries and have over 800 projects worldwide to date. And actually, that's a perfect opener to talk about how we use the data that is provided from the charging stations to our backend. And that's what we have explored and are still exploring with you.
Yeah, exactly. That's kind of where we come in, right? To help monitoring some of these, some of the measures coming out of these chargers, and just make sure that we can make sure that they're running at the 100%, efficiency, and make sure that any repairs that need to be done, we're fully aware of those before anything, can kind of go wrong. So maybe we want to jump in and talk about where, why we came in and where, Senseye fits in with this entire project. Starting with perhaps, the monitoring of these chargers across your various customers. So I don't know if you want to jump in with some of the measures that we began with. We can kind of carry on from there and talk about how we progressed and updated what we were using.
Yeah, it's of course, and I think it's always good to have some examples to make it a bit more tangible. So I was talking about the market segment of electric buses and electric trucks. So one of our key customer groups are bus depot operators. So just imagine a bus depot, and the operator needs to make sure that his electric bus fleet is available at the right time with a sufficiently charged battery. And we need to find ways to maximize the availability of infrastructure. And what we, for example, and that's where I can tell you one example, is what we have found out is, for example, the connectors of our charging stations and of all charging stations in general. There is wear and tear that can happen, for example, when there is vandalism or the connectors laying on the ground, someone stepping on it, a vehicle driving on it, or there's even in wintertime salt ingress, and it can deteriorate the pins that are in the connector.
Yeah.
And that means this mechanical damage, we can already, and we know now with our project, we can measure this and we can see trends and even predict that there's mechanical damage, and we can act upon this. That means if we know that in advance, we can, for the next field service visit, we can send a technician out there to, first of all, look at the problem, and we can make sure that he has the spare part with him and he can exchange it. So this is a perfect example of sensor data that we take, that we even do some calculations in the background, because it's about the difference of the temperatures between the DC and plus and DC minus. And it's just one example of being able to predict that something can go wrong.
And it's my understanding as well that one of the challenges with this is that in different environments, these connectors can degrade at kind of different rates. So having a fixed maintenance schedule isn't always appropriate for some of these. For example, we could have some charger connectors which are absolutely fine for a very long period of time, and some that might have a lot of dust buildup if they're in particular environments, which may start degrading in a faster time period. So in these cases, we want to be able to monitor those specific, like charger specific and location specific.
Yeah, and there are two things to it. First of all, the example that you mentioned is also a very good one. Because, for example, we have filters in the charging stations that make sure that there's only very, very limited dirt ingress in the charger itself, because we have fans and we need to suck the air from outside to cool the inside and bring the hot air outside. And depending on the environment, so a dusty environment, and also depending on the operations, so charger that's in operations very often, we see these filter mats could be clocked in different strength, or it could be clocked differently. And we need to see that, because the filter mats ultimately need to get cleaned and or exchanged. And here again, as you said, a fixed maintenance schedule for that does not always make sense. And if we can monitor it, and the second thing is, if we can have an overview of the entire fleet and learn and have per geography, per any other indicator, potential to understand where are the weak points and where are the weak areas, that makes us even better in achieving the uptime that our customers expect.
Yeah, I think those were some of the two key outcomes there, right? Where we've got monitoring and visualization of that data and how that compares across different assets in the fleet, locations, that kind of thing. And then also being able to, analyze that data and determine what the degradation looks like, what early warning signs are there in the data for us to be able to say, okay, this is now the filter needs replacing, this is the connectors need replacing, technician needs to go out and investigate, that kind of thing. And, that's what we ended up developing right across the project. I think maybe it's a good time to jump in and kind of mention how this was quite an evolving project, right? We started off with, just some chargers and just some of the data. And as we went on, we started adding more chargers into the mix, which allowed us to do that analysis across different chargers in different locations. And we also added different types of data sources to allow us to monitor a wider variety of potential issues. And we also had, a key team member on your side, Diogo, who was initially monitoring what was going on with the chargers. And what that meant was that having somebody on your side who was monitoring the Senseye app, but also had that knowledge of the chargers and your internal systems, means that, they can, the customer takes a strong role in the development of the project and increases your understanding of what's going on, as well as, my understanding of what's going on.
Yeah, and you brought up a couple of points so you are the condition monitoring expert. We are getting there. Yeah, so you have probably seen this in a couple of projects until now. I feel the way we have managed it is probably quite normal. It's a journey. So the way to predictive maintenance is really a journey. It sounds simple, but when you start, you will find out that it's maybe not that simple, because there's a lot of challenges that you are facing. And that's why I like the approach that we took. So we started with the feasibility study even. Yeah? And the focus of this feasibility study was that we identify the areas that we can tackle that have the highest business value.
Yeah.
And that's, to start with, one of the most important learnings that I have. It's also about promoting predictive maintenance and applying this technology in the organization. And ultimately, there needs to be a business rationale behind it. So the exercise we did, so our experts, our service experts, R&D experts, together with you, was absolutely crucial in the beginning to have feedback, to have support within the team, and to focus on the right things, because you can also overwhelm everyone when you do too many things at a time. So it was good to tackle one or two use cases in the very beginning, start with a couple of chargers, and just make sure that the data transfer is right, and then move on from there. So
yeah, 100%. You need this like iterative process of building it up, right? Because if we jump in and we have everything in there and everything needs to be configured, we need to create all sorts of, derived measures across the board. We need to train everybody on how to do everything and look for each individual part. It's a much easier process when we start off with, the basics, and we start building up from that point. And then as everybody becomes more familiar with the process, with the app, with the data that we're seeing, because it might also be, the first time that we've seen the data displayed in this specific format, then you can build up on that and make it more complex to solve more use cases and give greater insight amongst all of these different facets of the data.
Yeah, and at the same time, it's also a bit trial and error. I remember that, once the data transfer was established, it was a really great moment. Data coming in, seeing that we more or less instantaneously, we have a great visualization with the Senseye Predictive Maintenance. So it was very comfortable and user-friendly to work with. So seeing the timeline, being able to drill down, leave comments, and so on. So this was really cool to see. And then the real work came when we really tried to understand the data and get the insights from the data, because it was like new territory also sometimes for us. So we had assumptions, and I would say, looking back, a lot of assumptions hold true. So the use cases we have defined, for example, for the temperature of the pins that I was mentioning before, this hold true. So we were able to measure it. We are able to see trends, and our R&D team and our service team confirmed this with real live examples that we are now able to measure and monitor, for example, for this use case, and create a business value. But I also remember we had other sensor data that we thought would be helpful, or where we thought it's the right sensor information, but we found out that the assumptions we had for a specific use case was maybe not helpful. So it was also there important then to just switch to the next use case and to have really a list of use cases ready to move ahead.
Yeah, exactly. And I think, within Senseye Predictive Maintenance, we've got, the hiding and muting of measures, which means that as we've gone through and we've tried different things, we can always turn them on and off, as and when things work. So you do have that customizability there to really drill down on those specific cases that we know work after, looking into the data some more. Yeah.
You mentioned derived measures. I'm not sure if everyone understands. Maybe you can elaborate a bit on this, and then I can sure. on it.
Yeah, so of course, typically when you're bringing in data from various customers, they've got their sources of data, which we're just going to call, measures within Senseye. What we can then do with those measures is we can edit them in some way, perform aggregations, take specific statistical measures, manipulate them. Some really common ones are things like, filtering out 0 points. So, if the machine's off, we don't really want to know about that. But, that goes from, basics like that to more advanced features where we're deriving an entirely new measure out of that, using maybe some kind of relationship that we're aware of. And in doing that, it means that, for example, if there was only a few measures that a customer had, we could derive, 2 or 3 more from there and give a much deeper insight into specific problems. Not that that was an issue here particularly, because, of course, we had access to quite a lot of data. And it was more of a case of finding ways to kind of represent that data in potentially more easy to comprehend ways for the algorithms. So I know that was specifically for the case when we were looking at things like, anomalies and trends and the relationships between, say, like the 2 pins, so that temperature difference rather than just the temperature of one pin and then another pin, because, they can heat up. But the key difference between those is what we were more interested in. So we can still monitor those initial measures, but then we also have those derived measures too, which means that we can have that insight specifically targeted to what we need to look at.
And adding on this, what I really liked within the project is that we were not always dependent on you and on your developers, but some of the very essential features like setting up the derived measures, as Jordan explained, we could do within our team. And that also makes, for us, and I guess for a lot of these similar projects, makes a lot of sense, because ultimately we are the domain experts. And we are the service experts. So we know from field experience what can go wrong. We can derive the use cases. And we have the R&D knowledge to map the sensor data that is available to the use case that we have defined. So ultimately, we can and want to try out spontaneously and by ourselves. And that is you are providing within your app a very user-friendly way. And I would say no code environment to do these derived measures and to ultimately, let's say, rearrange some of the algorithms and how they work. That was really good and is still good in fine-tuning. And that's maybe one of the steps of the evolution. It's like you have an assumption, you try out, but then it's a lot about fine-tuning and realizing the assumptions. And that's why it's good to have this functionality also in our hands.
Oh, definitely. I mean, I think that comes back to what we were saying as well about the entire project as a process, right? To begin with, I'll be setting up a lot of measures, derived measures even, and working with you guys to show you how that works. And then once you know how to operate the derived measures functionality, you can pick up little things that happen that you might be thinking, oh, this is a bit strange. And then we can go back you guys can go back into the derived measures and say, oh, well, if we just tweak this here or add this filter in here, then it will make the data far more easily readable by the algorithms. And that's what we did here, right? And what that resulted in is a lot of derived measures which were much more accurate. So we were having less false positives by the end of the project, but that's a refinement, right? At the beginning, we were getting quite a few anomalies popping up. We're thinking, why is this happening? But there's some, niche parts of the data which we might not have been aware of bringing it in that you realize, okay, well, we need to put a filter in here or we need to adjust the thresholds here. And what that means is the data actually comes out in a much more readable format. And I think that's definitely what we have now. Because for sure, without jumping ahead too much, we do have some nice cases that I've seen recently.
Yeah, and what I also when I think about the progress we made, and maybe it's also a key success factor, that you need, in doing these projects, you need to have a good and easy way to document the insights. And that can be multifaceted. So one thing is, of course, you need to give feedback to the algorithm. We need to be able, and that's also very, very well solved in your app. You need to feedback if the case that was raised by the algorithm screening the data was helpful or not. And on top of it, and that's what's also quite nice, you need to document maybe a root cause analysis. You need to
Yeah.
be able to write notes and so on. And this needs to also be taken into account then by the next case detections. And that's what's also quite nice. So I cannot emphasize enough that there's a lot of manpower involved in getting insights from the data, documenting it, fine-tuning it, and make the algorithm work in a way that is suitable to the use case that you have defined. And that is often underestimated.
Oh, definitely.
We also found out that it can be really time-consuming, but it's absolutely worth doing it.
Well, that's the thing with AI, right? When you've got an AI-driven product, a lot of people think that there's just a magic box where, you know, you just give it your data and it'll say, yeah, okay, these are all your problems. This is the solution to your problems. But really, it's a bit more involved than that. You need to provide this expert technical information. And we can do that within the Senseye app via, you know, notes, adding things to the watch list, case feedback reports, root cause analysis, like you said. And all of this feedback helps provide, you know, better context and better insight in the next cases that are raised. And you know, maybe something else to mention here. Oh, you go, Stefan.
Yeah, and I really think that a lot of these projects don't like have their full potential because of maybe some impatience that there is, that the results are, maybe the first results are pretty cool, but then there's not a lot of progress.
Yeah.
And that can be due to a lack of expert commitment and time commitment that is absolutely needed to make these algorithms work.
Yeah, definitely. I think there can be a big misconception about the amount of effort that is required to make, you know, a solution like this work. But if you don't put the effort in, I mean, there's a big saying in AI where, you know, garbage in, garbage out. If you don't put the effort in to make the project, you know, look good and make your feedback good, then the feedback you get from the app and from the algorithm is also not going to be good. But if you put that effort in and you give it the information it needs, then it's going to pay that back to you.
Yeah, but maybe let's not scare everyone that delivering predictive maintenance projects is super high effort. I just want to make the audience aware that it's not. That it's not working without any expert knowledge and domain knowledge. So the team, there should be a dedicated team member providing domain knowledge to the project on a continuous basis.
Definitely. Well, it's a two-way street, right? You need that good project team that can help deliver all of those parts of the project, right? Because otherwise you do have that missing aspect. But if you have that, then the project will run really smoothly and you'll definitely get all of the outputs and the feedback that you would want to be getting from the application.
Yeah.
And maybe another quick point here on the case feedbacks as well. I know that it's only been online for a little bit of time, but it's worth mentioning the new beta functionality within the case feedback that you guys have been testing for us within the new generative AI feedback. So that's a new page which replaces the existing case details page, and it just drops back and looks at a lot of previous cases, even more so than we did before, and can provide a generative kind of feedback. And, you know, I'll let you say a few words on this as well, Stefan, but within using something like that, you also need that good feedback to begin with, right? And I know particularly for your case with e-mobility is we could have the people, you know, the tier 3 technicians come in, give this really in-depth feedback to begin with. And then as the application learns that, it can feed back to, you know, like different levels of users, how to solve certain problems, what certain aspects of the data could mean, what certain detections could mean. And then it means that everybody, or all users rather, would have a very good chance of being able to use the more complicated features of the app without having to escalate up the chain.
Yeah. A couple of words on it. Maybe let's take one step back. For a service, like for a service expert or for us at customer service, it's absolutely important that when, unfortunately, a problem with the charger occurs, we need to be really fast in solving it, because uptime and availability requirements are very high, which is absolutely understandable. And there are some errors and events of the chargers that we know and that we can act upon. So we know we have a recommendation right away. I give a very simple, so we know when an emergency button is pushed, because it's also a message to the back end. And of course, what do? You have to release it, and we observe if the next couple of minutes the emergency button is released. Otherwise, we inform the customer or the region. So like this recommendation for a certain error, in a lot of cases we have already. But in some cases we don't. For example, with any trend that we detect on the clogginess of the filter, maybe also with communication. And there, this recommendation system based on large language models and your co-pilot really comes into play and can really have a lot of strength. Because what I have observed so far, even with, I would say, still quite limited input on documentation, your co-pilot helps in understanding what the problem really is. So I've just screened it a couple of days ago, and I was positively surprised, as well as giving recommendations. So, and this is a good start. Again, it needs to have retraining, but you have now one place to go for a service technician. You just look at this case overview, supported by the co-pilot, and you have everything from what happened, when, how long, what is the potential root cause, and what are potential resolutions to the problem. And that's coming back now to what is important for us in customer service. It's exactly that. When a problem occurs, you don't want to be stuck in a couple of hours root cause analysis. So the more automated support you have, the better. And that means increasing the uptime of our charging infrastructure. But it's a way to go. Yeah, it's like this technology is out there. It's everywhere. But I guess a lot of people hopefully know that the training is involved, especially when it's not like ChatGPT where 1 million of users are using it, and there's a lot of learning in the background automatically for these industry solutions. The feedback needs to come from us.
Yeah, exactly right. It doesn't know everything,
and it's a limited number of feedback givers, and that's why it's so important to have this feedback and have this mindset also in the teams to work with it.
Definitely. So it's been great to have the chance to run that beta test with you guys, and hopefully as we collate the feedback and improve it, we'll see it almost replace the case details panel and give a lot deeper insight. Good. Well, perhaps now, Stefan, we can talk about some of the successes that we've had.
I think the hour would not be enough to talk about all the successes, but
maybe some of the highlights then. Yeah,
do some highlights. Yeah, but there are also lowlights. But it's just the way these like new technology projects go on.
Yeah, definitely. That's the thing, right? But I've been very happy with some of the cases that we've had through. Even, at the beginning when like we were saying, it's a process that we build up. And to begin with, when we just had, a few sources of data, we were even getting some insights then. I don't know how in depth you want to go with some of the explanations here, but I know the first case that we had was to do with a double battery truck. And we were seeing, some of the measures spiking in places where they shouldn't be. When we went and investigated that, it turned out that, this was before we knew it was a double battery truck, that we realized it was an issue when it was flicking between the first battery and the second battery, which was causing, the spike. But after seeing that, that's, a good documentation of the actual, the measures that we had being the correct measures. and was focusing in the right places, because it gave us the insight to have a look into that and realize that that was, a bug that we needed to change.
Yeah, that was one of the first successes where I think we even surprised our R&D and like, oh wow, how did you find out and which data did you have? So that was really also a very good moment in the project. We talked a lot about the temperature measures. I think it's we covered this already. Another use case that we are looking at is the connectivity of the charger to the backend. That's a common challenge. Just imagine, so it's a 3G, 4G, 5G connectivity via a router to the customer backend to our technical backend, and it's absolutely crucial that this is like online 100%, because it's crucial for authentication of the user and the vehicle, but it's also absolutely crucial for us to monitor the technical health of the charger and to even act via rebooting maybe the charging station. So it's absolutely crucial, and it's not always a given. Although you have a router in there, it's all standard. So one of the exercises we did is we looked at a large fleet, and we identified router signal strength values. So there are even 4 different ones for our router, and we were able to see patterns of chargers that even at one location there was a charger that had a lower connectivity, and in some cases we were even able to find that the router signal strength, once they go below a certain threshold, it's critical for the connectivity. So we also learned or trained a bit the algorithm that it's not only using the thresholds, but it's able to show us trends and anomalies with the connectivity, and we can act upon it. Maybe the signal needs to be strengthened because there's an obstacle in the way or whatever, but it's something where we have a data-driven analysis of certain sensor data that is important to keep the uptime of the charging stations. And that was also nice to see that it was pretty easy to set this up and to get the first insights for the connectivity.
Yeah, definitely. And that ties into when we started turning on more of the algorithms as well, right? Because as you said there was the trends, but also, the thresholds. And once you have those thresholds set, we can look at, degradations towards that threshold. So we can say, okay, it looks like in a few days that we're going to hit that mark if something's not rectified here. So it was a very nice time to kind of come in with another use case that we can try and identify, as well as different mechanisms within the app which allow us to identify issues relating to those specific use cases.
Yeah.
And also to add on to the temperature ones, I've been, writing up some of these use cases and success cases recently, and I've just been running back through the all the information, the root cause analysis that we've done within the app, and started documenting those properly. And I've seen within there that we have, temperature related cases that have appeared, and the root cause documentation is, that there's been issues with the connector. So it's really good to see that we actually have the tangible proof that what we expected to see via these measures is actually getting picked up by the app, and is being recorded and fixed from these detections.
Yeah. And one big advantage of this is I talked about the value proposition of predictive maintenance before. Is of course we can monitor, we see trends, we can early on react and replacing components, we can optimize our maintenance routines and so on. But a third one is definitely that we even become more experts of our charging infrastructure. So we are already the absolute experts, but there's even some details that we learn by looking at the data more carefully, and we can feed this back to also our R&D. So that is also an important loop when we talk about lessons learned and success factors. this project here with us, it's not a silo project. So it should be integrated in the entire organization, especially service, R&D, but also quality. And there need to be feedback loops on a regular basis, because there are learnings that go far beyond having a faster service. So we can maybe even improve our product even more with the insights that we have from the data.
Yeah, it's like you say, you need that support across all the departments, because their support is, one, valuable to the project, and two, the insights from the project are going to help everybody, and the experts only remain experts because they're continually learning, and hopefully that's what projects like this allow you to do, and really dive into the insights of the data that you might not always be aware of.
Yeah.
Good, excellent. So maybe do we want to say a few words on where the future of the project is going to be? Because this was a big project, but this is a kind of very much a pilot stage of the project, where we're looking at the initial insights and where we could potentially go from here.
Yeah, sure. Looking back, it was it is still a very successful project, because we now have the proof that there really is a clear value proposition for Siemens and for our customers in predictive maintenance. And it's not only a clear proof, it's also we have a technical proof. So we can do it already, and we can equip ourselves even better in the future to use data to improve the uptime of our infrastructure. And we now evaluate all the learnings, and this project, or let's say this initiative, of course, needs to be put even on more solid and bigger foundation, and that's something that we prepare to scale this for the future.
Definitely, yeah. Okay. Well, thank you very much, Stefan. It's always been a pleasure working with you, and it's been great working Siemens department with Siemens department. Right? It's a nice change of pace. But you and your team have been great. Pleasure to work with, and thank you very much for joining us today on the podcast.
Thank you very much. I only can give back all of this. So thanks for that, and it is a pleasure working with you.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.